So is it possible for all of you to turn your cameras on? That would be great. We would be able to interact much better. All right, that's great. I can see Amrita here, and there's Radhe and Nuki. That's great. Okay, so let me introduce myself. So I am Leva, your chemistry faculty at Glecta. So, as per the promise, we are here with our chemistry mock discussion today. I guess you all were there on Saturday for maths and chemistry session. And, we said, no, you weren't. Okay, in that case, you can call to the numbers. They would share the link to, have a look at those lectures as well. All right. You do not have to worry about it. So, right now, we are doing a chemistry mock discussion. And, just after this one, you would be having your biology lesson. So, make sure that you would attend both the lessons. All right. That would be really helpful. You're going to enjoy both the lessons for sure. And if I would like to tell you, who is Glecta? Glecta is a London-based tutoring platform that, takes lessons from year 1 to year 13 for different boards and for different subjects. All right. And now we need to talk about our chemistry mock paper. All right. I guess that, for those, let me tell you, you need to keep on responding because this session is about you teaching. All right. You would have to give answers in the chat box to all the questions because I would be doing some tricks and tips. You just need to use it and tell the answers. All right. So please be active on the chat box. This mock discussion is that for paper 1. For different boards, it would be quite helpful. You would get to know which kind of questions are being repeated. You know what? Same type of question is repeated in different papers. It's just that either they change the language or they change the example. You need to understand the difference, all right? This would definitely be helpful. If I would talk about the pattern, let me tell you, all the kids, if you would be giving your GCSE paper, there would be a margin, all right? There would be a margin. You do not have to write anything outside that margin. Most of you might be having your mocks, right? Okay, is there anyone, like, could you tell me if most of you are there in year 11? Or like who all are in lower years? They can tell the years as well. I would like to know. Like, are you all for your GCSEs? Would you be giving GCSEs this time? Not really. Okay. And what about others? Probably. So you might want to, start practicing your mock papers as well. I can see some of the messages. Oh, year 9. That's great. You want to start your preparation so early. Amazing. You would get an idea how to attempt it. Okay. Wonderful. So we have some, okay. Oh, there's someone in year 5 too. All right. And what about Imesh? Would you turn your camera on, Others, Viraj, please turn your cameras on. Imesh, you need to turn your camera on for sure. All right. Remember, don't write outside the margin. All right. And if I would talk about, you would be having a lot of questions. There would be NCQs. There would be 1 or 2 marker questions. There would be 4 to 6 marker questions as well. Just be careful. 4 marker question doesn't mean you need to fill half a page. Space in your GCSE paper is quite limited, all right? You need to write 4 important terms for 4 marks. We need to learn that today, all right? And I guess, let me tell you one thing. Don't you think so? Like science as a whole, physics, chemistry, biology is too much? You would have to do so many notes. You might be completing so many notebooks by the end. It would be very difficult for you to revise all that complete topic a day before your exam. You're nervous, there would be so much of pressure. Make mind maps. That would be very helpful. I would be showing some of the mind maps here, and then you need to attempt the questions. You would surely be able to attempt most of them. All right. So I hope you all are ready. Just, wear your virtual seat belts because we are on a tour to learn chemistry mock test, how to attempt chemistry mock test. So here you go. We have our first mind map. I hope you know that the first chapter is that of atomic structure. and periodic table. But right now, let's talk about atomic structure. For those year 9 kids, even those year 9 kids might have, had an idea about atomic structure too, right? If not, you would get one. Atomic structure of an atom. We didn't know about that atom contains protons, electrons, or neutrons from the start itself. No, we didn't know about that. There were different theories. So if I would talk about the first theory that came forward was that of John Dalton. The name of the theory was billiard ball. All right, if you would want to take screenshots along with, you can take them. There were three important points, just three important points. Atom is indivisible, which means you cannot break down atom any further, all right? Second point about it is that atoms of same element are identical. I'll tell you what it is. Oxygen atoms. Both the oxygen atoms would look exactly the same. They wouldn't look different. That's what it is about. However, hydrogen and oxygen would completely be different from each other. That's what this point is about. The third point that you need to know is that different atoms form new substances. Do you know what hydrogen gas? If you would bring a lightning splint on it, it would burn with a pop sound, and oxygen is necessary for combustion. The students who might be taking lessons from me should know that oxygen is necessary for burning to take place. Both of them combined together, you get water. It extinguishes fire, a completely different substance now. So that's what it is about. The second theory that came forward was Thomson's plum pudding model. What was that? Thomson's plum pudding model. Now, what he told was, first of all, he discovered electrons. You should know he discovered electrons, all right? By what practical or by what experiment? By cathode ray tube experiment. Just know the words, the terms. Cathode ray tube, right? And when he talk about his model, his atomic model is called as plum pudding model. Remember, by then, nucleus, protons, neutrons, they were not known. He just said that your atom would be, would be like a plum. I hope you all have seen plum, right? So the red color part in the plum is called as sphere of positive charge, and the yellow colored ones is called as sphere of negative charge. And both of them, the amount of positive charge and the amount of negative charge, both would be equal. That's why your atom is neutral, right? Okay, now we need to move towards the third model, which is Rutherford model. Remember, your Thomson's model and your Rutherford model are very important for your exam. From 2018 to 2022, so many questions have been asked from this particular topic. I would want that from this mock test, if this question, like a question on both these topics, would be repeated, all of you would be getting those 4 to 5 marks. All right? All of you. I would want year 9 to year 11, all of them. And if I would talk about Rutherford model, he gave the experiment of gold foil, that complete experiment was called as gold foil experiment. This particular experiment is very important. If I would want to show you, the model is called as nuclear model. Rutherford model, also known as nuclear model. All right, there were certain outcomes. He used certain radiations, all right. Those radiations are called as alpha radiations. And if I would talk about the next, what kind of foil was used? The foil was a gold foil. The name suggests, the foil that you use is gold foil. And there were certain, observations. According to a nuclear model, not nuclear, according to the Thomson's plum pudding model, it was thought that all the radiations should pass straight away without any deflection. But whoa, what happened? They were deflected, all right? They were scattered. And the other observation that came forward was some of them went straight and they came back like this. They went like this and they just strike back. Just a reverse gear. You might be applying a reverse gear in your car. It's just like that. So based on these two observations, which went against plum pudding model, Rutherford told that there is a positive hard sphere called nucleus in the center that you know as atomic structure, right? But he said that electrons are revolving in fixed orbits. What? In fixed orbits. That's the place where he went wrong. And then came Bohr's model. So when you talk about the latest, Schrodinger's model is the latest one, but you do not have to do that in your, GCSEs. Just need to restrict yourself towards Bohr's model, which is that electrons are revolving in fixed orbitals. Remember, not the word orbit. They would confuse you with it. Orbital, not orbits. Or the other word with it could be shells. All right? It could be shells. And all these shells would have different energy. There would be different energies for these shells. I hope it's clear to you, everyone. All right. Okay. And yes, after Bohr's model, proton was discovered. All right. After Bohr's model, proton was discovered. So we need to move forward with our question. Quickly write down your answers in the chat box. I'm waiting for all of you. My chat box is right open here. You need to tell me the answers real quick. I'm waiting, everyone. So what do you think? It is. Atoms were first thought to be tiny spheres that could not be divided. Okay, all right. Try out. I would want more answers. Everyone, after Dalton's theory came, which model? And he discovered something. Exactly. Very good. A lot of you said electrons. If you remember, all right, all right. Iyana said electron. Elena said electron. Amrita said, that's amazing. So many kids said electron. Very good. So exactly, you remember plum pudding model? He discovered electrons with the help of cathode ray experiment. We need to move forward towards our next question now. Quickly answer it. Okay, Amrita, you would find hard, but I guess that you would be able to answer, right? You said electrons. So you got the answer correct. Okay. So what is this model atom? Like, could you tell me about it? Yes, it's electron, plum pudding model. Exactly. It would be plum pudding model. And C part need answers for that as well. C part, quickly, I need answers. Alpha particle, very good. You all are quite smart. Looks like you already know about it. So D part, quickly need answers on that as well. Type your answers. I'm waiting. A lot of you got your answer correct. Amazing, Queen. Even Queen got it correct. Need answers for this D part. What do you think? Which scientists first suggest that electrons orbit the nucleus at specific distance, which means in the orbitals of different energy level? Who told that? That was amazing. You all are great. Okay, let's move forward. Now, for these questions, they're quite easy. Take a screenshot. That would be your homework. All right. They're very easy questions. I believe that you all would be able to do that. All right. I'll be moving forward. And again, this one. Let's see who would get this correct. I'm waiting. Let me check who would get this one correct because that's quite theoretical. You need to answer this. Come on, I'm waiting for you all. All right, looks like that's something confusing. No text. Sports arena. Okay. Very good, Krishna. You got it correct. Exactly. For this one, it would be a sports arena of radius 100 meters. That's what it is. We need to move forward towards our next one. Now, take a screenshot for these questions that you need to work upon in case of very good, in case of atomic structure, difference between nuclear model and plum pudding model have been repeated so many times in your past year papers. Changes brought by Neil Bohr model, isotopes. You need to know what isotopes are, an atomic number and mass number. These definitions are very important for your paper. If you're going to do it, okay, it, like It's not possible to unmute for now because the session is going on. If you have any concern, you have those numbers at the bottom. You can tell the team or you can type your concern here. All right. And I need to move forward for that. In here, like what you need to talk about is this particular question. Students, listen. This question for 3 marks is being repeated in all the papers, of all boards. All right. You need to know it. Make sure. I hope you would be getting, around good marks of this question. If this 3 mark would be for permanent that you're going to get in your paper, would you just tell me before learning it? If you will learn this topic here, can you like assure me that you're going to get these 3 marks for sure in your paper from this lesson today? Okay, let's learn it. So in order to learn this particular question, titanium and iron, they're transition metals. You need to calculate their relative atomic mass. Have a look at this table. Different atomic mass of the same element are given to you over here. And the atomic mass is also given. So as you can refer to the y-axis, you need to talk about the percentage abundance. Just have a look, read graphs, all right? Have a look at these values, mark their percentage abundance, and what you need to do is the formula would be relative atomic mass. Just write this formula, it would be very important. Atomic mass equals summation. You need to sum it, all right? Percentage abundance times its atomic mass. And then you need to divide your answer with 100. All right. There's so many percentage abundances here. Like, for example, if I would talk about for titanium 46, it would be 8%. All right. Or I would say it would be 9%. So you need to do 9 times 46. For titanium 47, it's 8. So it would be 8 times 47. For titanium 48, it would be nearly about 74. So it's 74 times 48. Similarly, you need to take it, add all of them, and divide your answer with 100. Got it? Just tell me if you got it. You can tell me if you got it, everyone. Give me a thumbs up if you got it. Would you be able to do it? Yeah, sure. I'll be going back to the formula. Very good. Have a look, take a screenshot for this formula, and if you would try this question, you would get your answer as 47.91. Very good. Okay, so we need to move forward towards our next one. This question is not a part of your mock test. I've just added it for your practice. Take a screenshot and just try to do it on your own after this session, after your biology session too. So for those, who are new here, who might not be taking sessions, if they're interested, if they would want to, have a demo lesson or want to know more about it, we have a complete course for year 9, 10, and 11 with all the, services mentioned here. You can contact the team with the numbers given below. They will tell you for the further details. Now comes our periodic table. Learn to read periodic table. Everyone sit down for like 30 minutes and read it. See the symbols and just guess the name of the element. This part, 5-mark question for sure. And I guess that, you all should be able to get those 5 marks in your paper, right? Why to lose it when you all are so smart now? You need to learn the groups, all right? I'll be telling you in short that your groups are nothing but columns. And your periods are nothing but, if I would say, it's rows. So if I would talk about rows, this is your first row or first period, second period, third period, fourth, fifth, sixth, seventh. There are total 7 periods in a periodic table, like if you would see here. And if I would talk about your columns or groups, there are total 8 groups. As you can see the numbers, first group, second group, third, fourth, fifth, sixth, seventh, and the last one is called as 0 group, not the 8th one. All right, there are noble gases. The middle one is left, because they're the transition metals, and we do not count them. However, the topic is covered separately. You might be aware that there's a chapter called transition elements, right? That's what you need to refer to. All right. We have another mind map, Mendeleev's periodic table. Very important. So make sure you know the points. If I would tell some basic important points about Mendeleev is, you need to arrange elements in column having similar properties. Columns are groups. So if an element belongs to one group, they would have similar properties, right? And next is, if I would talk about the next point, they're arranged in the increasing mass number. I guess, do you all know? Okay, could you tell me your present day, or periodic table? Is it arranged in increasing mass order or something else? Type down your answer right now. I'm waiting, everyone. I'm waiting. What do you think? Like, all right, we have someone. Oh, my question is that, your modern periodic table, it's based on increasing what? Is it mass number? Krishna got it correct. Very good. Yes, it's atomic number, not mass number. Your present day, your modern periodic table is based on increasing atomic number. However, mentally one is based on increasing mass number. Right? Next is your properties, chemical properties, which they should fall under one column, right? And apart from that, Mendeleev was, he could predict the future. He left certain elements, he left certain blanks, and he said that there would be future, like elements being discovered. He was a magician, I would say. So these were the parts. Based on that, you need to answer these questions. Take a screenshot. I would want you to, like do it as a homework. Gallium is the first, is same group in the periodic table as aluminium. You need to suggest a state in which group or period it could be. Read the periodic table and tell the answer. Where's gallium? Gallium is here for your reference. What do you think? Which group it belongs to and which period it belongs to? All right, I've given you enough. All right, what three and what two, you need to mention it. You can send it to the team. The numbers are displayed here. All right, not an issue. Next one. All right, describe how mentally predicted the properties of gallium. Everyone, very important. Gallium, this particular question was repeated in different boards, not in the same language, obviously, but in different boards altogether. You need to know about gallium in case of Mendeleev periodic table. You need to describe how Mendeleev predicted the properties. All right. You need to write the 2 mark would be that on going from, in a group, in a group, they should have similar chemical properties or similar properties to other group members, all right? Properties with other group members. That's how 1 mark here and 1 mark here. You're going to get your complete 2 marks. The gallium belongs to one group, and to that particular group, its properties should match with other elements as well, specifically chemical properties, I would say. Next one. All right, you need to state how you know that calcium is a metal and its position in the periodic table. All right, let me tell you. Do you know the leftmost elements, group 1, group 2, and group 3? All of them are metals, whereas the cornermost ones, they are the non-metals. So, since calcium belongs to group 2, you just need to write that it belongs to group 2. So it's a metal, 1 mark. Is it difficult? You just need to know about periodic table. That's it. Just give yourself, that 30 minutes to read it and explain how the electronic configuration of an atom of potassium is related to its position in the periodic table. What you need to do is you need to write its electronic configuration based on the atomic number. And then because it would have, around 4 shells being filled, it would belong to fourth periodic table. And if I would talk about the last electron being added, that is 1, it would belong to first group. You need to do it on your own. I have given you enough hint, right? You all would have to do this particular question on your own. All right. Here you go with your another mind map for sure. Group 0. All right, you remember the last one that I told? They are all noble gases. All right. And if I would talk about the properties, their melting point and boiling point increases. And there's a reason because of increase in intermolecular forces. Intermolecular forces, very important. The density also increases, reason just the same. Now, if I would talk about group one, these are alkali metals, and because they're alkaline in solution, they would have low melting point. Take the screenshot. This particular, mind map would be very helpful for you. All right, I'll just go back. You can take a screenshot for your reference. All right, that would come handy for sure. Like you can type your question, like if you have any, Dante, like you can write your answer question in the chat box. I'll try to solve it right now for sure. If not, you can type, you can type, if the name is Dante, you can type your query. Next is group 7. These colors are directly asked in your paper. Take a screenshot. Know that fluorine is a yellow gas. It's chlorine is pale yellow, bromine is red. Just take a screenshot and then I'll move forward. Okay. Let's move forward with our next question. So these particular questions you would be doing on your own with the flow charts that I have given you, and that would be your homework. Please take a screenshot. You should know how to do it. That would be really helpful. Okay. I just wanted you to take a screenshot for this one as a homework, Dante, and you can take screenshot for this one as well. All right. Explain why reactivity of elements changes going down to group 1. This is 4-mark question. 4 important terms or 4 important lines. That's it. When you talk about on going down the group, the first point is that, reactivity increases. What happens? Reactivity increases. Why? This would give you 1 mark. Second question, why do you think so this reactivity increases? Because the size of the element increases. So second point is size increases. Another 1 mark. So what happens when size increases? The effective nuclear charge decreases, hold over outer electron decreases. Another 1 mark. And the last part is due to which electrons are lost easily, hence they are more reactive. What do you think? Was that too difficult? Do you have to write complete, page or paragraph onto it? No. These 4 words, more than sufficient. Right? I hope it's clear to you. Do you have any more doubts? Is it clear, everyone? Okay, that's great, Dante. Okay. Now you need to draw, the structure for sodium oxide or sodium oxygen. This is an ionic structure. Remember, if you're going for paper 1, your structures for covalent molecules and for ionic molecules that are so important for you. You need to do it on your own. Take this as your homework. You would have to complete them. Draw the structure. You can take reference from your book. You need to know how to draw different, structures for ionic as well as covalent molecules. All right. Now the question comes, why is oxygen described as, it is being reduced in the reaction between sodium and oxygen? So what do you know about reduction or reducing? Type down your answers. What's oxidation? What's reduction right now? You would get your answer from your own definitions, Type down your answers right now. I'm waiting for you all. You can do it. Everyone. Waiting for your answer. Do you know what reduction and oxidation is? Oxidation, gaining electrons. Whereas if I would talk about what's reduction then? Okay. All right. The different definitions. Let me tell you that when you talk about, reduction, since the question is about reduction means gain of electrons. What does it mean? gain of electrons. Yes, it's about losing oxygen and gaining hydrogen, but for this particular one, this is the answer. Reduction is because oxygen is gaining electron here, right? Okay, all right. Just a bit of correction needed. Reduction is gaining electrons, oxidation is losing electrons, all right? Make it correct. Just a bit of confusion can actually, like, why to lose that 1 mark, just because of small confusion? I don't think so. That's worth it. Next is sodium oxide has high melting point. I'm giving you a hint. It's ionic compound. And since it's an ionic compound, this would give you 1 mark. Now tell me about those 2 marks. How can I get those 2 marks? Everyone, can you tell me why do you think so ionic compounds have high melting point? Any guesses? Very good. A lot of people, are answering the questions. That's impressive. Looks like you're gonna, ace your GCSE exams this time for sure. Up to grade 9, maybe. All right. Very good, Krishna. You seem to have good concepts. I'm impressed by you. All right. Type down, type down. Others? All right. Let me tell you. Since sodium oxide is an ionic compound, it would have, giant lattice. And that giant lattice is there, which is strong. All right. Giant and strong lattice. Why is it strong? What's there in it? Because they have strong intermolecular electrostatic attraction. All right. They have strong electrostatic attraction. They have strong electrostatic, electrons or charges. The word itself suggests you would have a positive charge and a negative charge. The attraction between those charges are called as electrostatic attraction. Opposite attracts, So this general rule is valid here, and that opposite attract is called as electrostatic attraction. All right. Now take a screenshot. These are some more important questions that you need to move towards or learn thoroughly about periodic table. You need to know, melting point and boiling point would be given. You would have to, select the state of that particular object, like of that element or compound. The difference, Mendeleev model, electronic configuration, and then you need to know how to read your periodic table. Okay. Everyone, like this one, if you would talk about your rapid, Glecta is launching a rapid course very soon. Rapid course, whole syllabus would be covered in short time, in limited time. However, in science, you just had a look at one or two types of those, mind maps. We would be teaching you whole concepts with those mind maps, and then we would be practicing questions and mock tests for sure. I guess this particular rapid course would actually help you to, reach your desired grades. That might be 8 or 9, right? All right. That's great, Paul. Let me move forward. So, when you talk about the next question, which is about how, all right, all right, Kavi, like, this particular session would be, if you would want to have a look at any particular topic again, you can ask the team, they would share the link with you, and you can just go over that recording again, right? That would be helpful there. Let's move forward where we need to talk about our question number 5, which is about bonding and structure. So could you all draw the structure of oxygen? Another important question of bonding and structure, which includes covalent molecules. You should know nonmetals and nonmetals combined together gives you a covalent molecule, right? Be clear with it. You need to draw. That would be your homework because this structure is quite easy. I believe it should be clear to all of you. Please tell me if you could do it. You have to take this question as a screenshot, as your homework, all right? Be part. Let's move towards the next one. This particular question is up to grade 8 or 9 level question. Not everyone is able to answer this. I would want you all to try and answer this question. And then I'll see whether you would be, like, we'll see how good you would be knowing about it. All right, non issue. All right, for low boiling point, it doesn't have low boiling point. It would be having high boiling point. Like if I would talk about, all right, for this one, let me tell you. Nitrogen is a gas at room temperature. You need to explain it. Why is it so? So first of all, you need to say that nitrogen is a small covalent molecule. And this small covalent molecule would give you 1 mark. The second thing that you need to write about it is that it would have weak intermolecular force of attraction. Intermolecular force of attraction, and due to which they are gas at room temperature. Right? These 3 points would give you 3 marks in this particular question. Let me explain that to you. Right? Okay. If I would talk about, you might be wondering what intermolecular force of attraction is. I'll just help you relate it. You might have heard of inter-school competitions, right? Where different schools would be, coming together to have a competition between each other, which means different schools coming together. Similarly, when you talk about intermolecular, there would be different molecules having some sort of attractions with each other. If this attraction is weak, this attraction is weak due to which molecules are far apart from each other, they would be in the gaseous state in that condition. All right. This question is important. Make sure you know it because in another paper, the question was about carbon dioxide. Why carbon dioxide is a gas at room temperature. Same story again, just the name has been changed. All right. Okay. So next one, graphite and fullerene are forms of carbon. This particular topic is very important in bonding and structure. I've specifically taken only those questions in your mock test that includes, that would be very important for your exam overall. They have been repeated in different boards overall, right? So if you would talk about this one, like tell me if you could tell me your answers. I would be waiting for your answers. If you're willing, when you talk about graphite and fullerene, they're forms of carbon. Graphite is soft, whereas and is a good conductor of electricity. One good point, but this question is a 4 mark. You need to have 4 important points. You need to tell about the bonding between them. What kind of bonds are there? Right? No, graphite that okay. Graphite would not have a metallic bonding. It's an allotrope of carbon. Carbon is a non-metal, right? How would it have a metallic bonding? Graphite is bonded to three different, it would have three covalent bonds. So you just need to write that in each carbon, they have three covalent bonds. All right. Three covalent bonds are there, and there are different layers. The different layers, and these layers slide over each other. Let me correct myself to make it more clear for all of you. So it would be these layers, they slide over each other. And one point that, Krishna said was that they have, free electrons, free, or I would say delocalized electrons. And if I would talk about, the layers, why do they slide over each other? They slide over each other. Let me just make it more clear for all of you over here. These layers, they slide over each other because they have weak attractions between them, weak force of attractions between them, due to which the layers just slide over each other like this, and hence they are soft. All right. So what do you think if this question was repeated? Yes, they have delocalized electrons for sure. Metallic, all right. They have delocalized electrons. If I would talk about carbon, I hope you all know that in the valence electrons, like carbon has 4 electrons in the valence shell or in the outermost shell. So these 4 electrons in the outermost shell, if I would talk about here, 1 electron, 2 electron, 3 electron, 4 electron, right? All these electrons would be going for covalent bonding. So one bond, second bond, and the third bond. Fourth electron is not undergoing any bonding. And this electron would be jumping from one electron to the one carbon atom to the other, due to which it would be, conducting electricity because of these free electrons. I hope it's clear to all of you. Next question is that, another lubricant is there, which is Buckminster fullerene. Why is it, a good lubricant? This particular question, Buckminster fullerene has very limited number of questions. It doesn't have a lot of questions. All right. The only thing that you need to write is that since its shape is more like a sphere, football, right? It has a sphere shape, so it rolls around, but just like a football. And since it rolls around, it would be acting as a good lubricant. That's what you need to write in this particular question. All right. And 2 marks would be for free. All right. You have another question for, ionic solid, which includes calcium and oxygen. You would have to draw the complete structure. Calcium belongs to group 2. And as you can see in the outermost shell, it is losing 2 electrons over here. That those 2 electrons would be lost and it would be gained by oxygen. That's the structure that you would be drawing would help you score those 3 marks. All right. And in the end, you need to tell the charge, the one that loses electrons. If someone is losing electron, they would be having a positive charge. Calcium, since it's losing 2 electrons, it would have a +2 charge. And if I would talk about oxygen, since it's gaining those 2 electrons, it would be having -2 charge. Do you want to know about the formula? Is there anyone who knows about the formula of calcium oxide on their own? Can you tell me? Right. If I would be asking for the CaO, very good. If I would ask for the formula of aluminium oxide, what would that be? You might have to know the formulas, right? So make sure you know it. All right. It's calcium oxide, Al2O3. Very good. When you talk about how to, reach out the formulas, have a look. Aluminium belongs to group 3. Metal, how many electrons? 3 electrons would be lost, +3 charge. Oxygen would be gaining 2 electrons. What you need to do is, you just need to take these numbers, cross multiply them, and send it to the subscripts. Not those multiplication, it's just crossing it to the subscripts without the charges, all right? So it would be Al2O3. That's how you can form the formula of any compound that might come across, right? Now, here you go with the questions on bonding and structures. If you're going to do these questions, I can assure you that you would surely get good, they would be repeated many times and you need to cover it. So take a screenshot so that I can move forward. All right. Next is question on chemical calculations. Would you be able to solve these questions? Is there anyone who's good with maths? Or is there anyone who struggles with maths? Tell me, I would love to know, like, who struggles with maths or who's good, who loves maths? Okay, so do you find it difficult to solve mathematical questions of chemistry? Would you want to know how to do it? All right, let me help you then. Okay. All right, I'll help you then. You don't have to worry about it because we are there to help you throughout. So have a look. The solution of potash alum, it has a concentration of 258 grams per decimeter cubed. Oh, that's amazing. So do I. Even I love maths. So you need to calculate the mass of potash alum if its volume is given to you, which is 800 centimeter cubed. There is one basic mistake that most of the kids would be doing, that they would consider concentration as moles per decimeter cube. So they would take the formula of number of moles over volume. You do not have to do that. Instead, you need to take concentration equals mass over volume. And if your volume that you're taking is in centimeter cubed, in order to convert that in decimeter cubed, you need to multiply your answer with 1,000, right? Concentration is given, volume is given. I need to calculate mass, rearrange it. It's always, just reciprocal. Just send it to the other side. That would be opposite. Take volume, cross it. It would be multiplied on the numerator. Take 1,000, cross it, send it to the denominator. So on rearranging, you'll get mass equals concentration times volume over 1,000. That's it. It's done. What you need to do is you just need to put the values. 250, like concentration is 258 times 800 divided with 1,000. And on solving it, you'll get your answer, and that would be 206 grams. I hope it's clear. Tell me if it's clear. Would you be able to do this if the question would be repeated in your paper? What do you think? Everyone, I'm waiting for your answers. Would this be is this clear to everyone? Or should I explain it once again? All right. Looks like it's mostly clear to all of you. All right. Yes, I can re-explain it. It would just take hardly 1 more minute to complete it. The formula of concentration is mass over volume. I'm just writing mass over volume, and then you need to times your answer with 1,000. You're multiplying this with 1,000 because the volume that is given here is in centimeter cubed. If this would have been in decimeter cubed, then there was no need to do that, right? I'll rearrange it, just cross it. While sending any particular value to the other side, you just need to cross it. So volume would be crossed, 1,000 would be crossed, but since V was in the denominator, it would go to the numerator. 1,000 was in the numerator, so it would go to the denominator. So your value would be mass equals concentration times volume over 1,000. This formula, 1 mark, putting values, another 1 mark, and your final correct answer, another 1 mark. I hope it's clear. We need to move forward. You need to find out its relative formula mass. Very easy. Take this as your homework. I would not be taking it. So you need to do it on your own. All right. Take a screenshot. Now, next one. If I would talk about this one, you need to calculate maximum mass of iron that could be obtained from 640 tons of iron oxide. How would you do it? Isn't it difficult? Like, tell me who would be able to do it or who would not be able to do it? Or who can try to do it? You can tell me in the chat box. I would be waiting for all of your answers. I really want to know whether you would be able to do it. All right. Okay. So in the meantime, I'll try to explain this. You need to calculate the maximum mass. First of all, 1 ton is equal to 10 to the power 6 kgs, or I would say, it would be the value of 1 ton over here. You need to calculate the mass. All right. Let me correct myself. It would be grams and not kilograms. So I'm helping you out to do this. No worries. You need to know that 1 ton equals 10 to the power 6 grams, which is a million grams. All right. And you need to calculate maximum mass of iron that can be obtained from this much iron oxide. Have a look. Iron oxide, I'm writing Fe2O3. And then you have Fe. First of all, we need to talk about in moles. All right. Have a look. The ratio of mole is 2 to 4. All right. 2 to 4, which means 1 to 2. If I'm having 1 mole of Fe2O3, my amount of Fe would be double. All right. So from here, we can calculate number of moles. So number of moles, the formula for number of moles is nothing but, given mass, which is M over MR, molar mass or relative formula mass. You need to put the value 640 times 10 to the power 6 over its MR, which is 56. You need to solve it, and you would be getting your answer in number of moles. Whatever answer you would get here, all right, you just need to double it. So your number of moles of Fe would be 2 times 640 over 56 times 10 to the power 6. That would be your number of moles. All right. Once you would get your number of moles, you need to again multiply it with its molar mass, which is 56. All right. A small correction that I guess I should make here. We were talking about number of moles of iron oxide, right? So that is 150, like 160 and not 56. So if I would solve it, that is 4 into 10 to the power minus 3. So double 2 times 4 is 8. So it's 8 times 10 to the power 6 moles of Fe. After this, you just need to multiply your answer with its molar mass. If you want to know the molar mass, it's already given to you, which is 56. Remember, relative atomic mass, molar mass, and like these values are same, or atomic mass. The only difference is there in its units. So you do not have to be confused that, oh, it's relative atomic mass. It should have been, molar mass. No, that's not the case. The values are just the same. So it would be 8 times 10 to the power 6 times 56. And that would be your answer. Since your answer is already there in grams, you need to convert it into tons. You need to remove this 10 to the power 6 value. So it would be 8 times 56. All right. And on solving it, you'll get your answer as 448 tons. I hope it's clear. A difficult question, I know, but you would be able to do it if you would try and practice more questions on it. Take a screenshot for the type of questions that would be important on it. All right. Electrolysis is one of the easiest topics. I'll be moving forward. Just take a screenshot. These would be your homework questions. All right. Now, if I would talk about reactivity of metals, like even these questions, when you talk about the answers, you need to choose the correct answer for most transition metals. These questions are very easy. All right, you just need to choose the correct answer. Try make a transition metal, mind map with yourself, and then try to answer them. Take a screenshot. I'll be moving forward with these questions. And for most of the kids, I have actually discussed this kind of question in the classes as well. So I would want my regular students to definitely answer this. And others as well, I would be waiting for your homeworks that you would be sending to the team. All right. And let's talk about reactivity of acids. So if I would be talking about reactivity of acids, do you know what acids are? Type down your answers. What are acids? Come on, I'm waiting for you all. Type down your answers. What do you think is an acid? If you know, let's see who knows it. What's an acid and what's an alkali? pH scale above 7. All right, you're saying pH scale below and above, but what is it? Is it acid or base? Okay, very good. And what does that pH, in that pH, that H means? H means concentration of H plus, right? Acids would be giving H plus ions into the solution. That's why if you would have to choose which ion do acids produce, your answer would be H plus. All right. Your answers would be H plus. To know about pH, the formula, how is it related to H plus? I would be excited if you would be, choosing, chemistry in your main subjects. We would be learning about the detailed theory about it. That would be amazing. All right. Now, I need answer. Let's see who knows it. All right. Bases would be giving hydroxide ions, which means OH minus ions in the solution. All right. Alkalis or bases would be giving OH minus ions into the solution. That's what you need to know for now. All right. Oh, that's amazing. Most of you know about it. That's wonderful. I didn't expect. Very good. It would be neutralization. All right. This particular question, acids reacting with alkalis, you would get salt and water. This salt and water means that your reaction is a neutralization reaction. There might be a question they would be asking whether this particular reaction is a neutralization reaction or not. You need to check if a salt and water is being produced, then it is. Otherwise, it's not. Right? Very good. Okay. Now, balancing is one of the most important topics, like I hope you all know how to balance it. So this would be your homework. And even your universal indicator, D part. Who knows it? Universal indicator turns purple in potassium hydroxide solution. What do you think is this? Is a pH? 14. Very good. Amazing. Amazing. Very good. All right. Take a screenshot for this experiment based questions. Titration is another important topic. You would be doing it. These are easy ones. So I would be taking those topics that most of the students struggle with. So just take a screenshot. You need to know about them. All right. Another question for you to know. In this question, I would want to see now how you all would be writing this answer. All right. You need to explain the process of titration in five important words, in five important steps. You know what titration is. That would be your homework. It's very easy if you're going to write big paragraph, even though, you might get it correct, but you would be wasting much time. So I need to see how you would be writing those five lines for these 5 mark questions. Some more questions, you can take a screenshot that are important, not the questions, but the topics that you need to work upon. All right. Now you have your like question on equilibrium. So based on that, you just need to calculate it. Take a screenshot. That would be another homework. Universal indicator. Yes, universal indicator would be a type of a liquid that you need to use. And take a screenshot for this question as well. And you need to write its equation as well. All right. This one is a last question of chemical changes that would be important. You need to suggest two important variables here. So remember, in case of any sort of reaction, your temperature and your concentration are the two variables that should always be kept constant. And highest voltage would be most reactive, lowest voltage would be least reactive. So magnesium is highest reactive and cobalt is least reactive over here. Another question, take them as a homework, try doing it. These are quite easy. D part includes your physics knowledge. Chemistry, like as you can see, physics in here. So try knowing it, and that would be amazing. Another one, and last one. Let's see who would get it correct. What's X here and what's Y here? Your biology teacher might be waiting for you. So would you tell me X and Y? X is your activation energy and Y is your energy change. Very good. Very good. Most of you got it correct. Very good. Okay, these are important questions. Now, do you have any particular question? I know you must be quite exhausted, but yes. What do you think? Any doubts? You can type down your questions. And in case you have any questions or query right now, otherwise, you can reach us out in these social media platforms or to the numbers that are being displayed below. If you would want me to come up with paper two, mock discussion as well, do let us know about your feedback. It would be great. We would try to make it more interesting and helpful for you all. All right. For extra, information, you can contact the team. Just reach out these numbers, and please be careful. Your biology teacher would be joining in a minute or two, so you would be getting a 2 minutes break, and after that, you need to join the next session again. Periodic table is just one table. Like it's not different tables being combined. It's just your groups and your rows, and that makes one table at all. So that's all from my side. I hope you enjoyed the lesson. Take care, everyone. Bye bye.